Hello, welcome back. So, yesterday we learned how to set up age questions. You worked on the front page of a worksheet. We had the informational box at the top that gave us little hints when we see certain words that they equate to certain things when we're setting up our system. So this was a pretty helpful little chart. Is, was, were, will be was the essential piece, and that was where our equal sign would be located. Now again, we're working on systems, which means we're working with more than one equation at the same time. So more fun. More equations, more fun. So we worked on this whole front side. We set them up together. If you didn't watch those videos, go back and watch them. They're pretty good. Because today we're going to work on setting them, not just setting them up, but we're going to work on solving them as well. So today's a new technique. We've already learned how to use what we call the elimination technique, also called the vertical technique, also called the addition technique. You know, we in math, we can't just pick one word, we got to use a lot. So the elimination technique was great. We line things up, we look for something to eliminate or cancel, and if it didn't eliminate or cancel when adding going down, we tweaked it a little bit and forced it to happen. Well, this type of strategy that we're going to learn today is very different. It's called the substitution technique. Definitely, I know you've heard that word in mathematics. It's a pretty common word. Substitute, something that we fill in for something else. Like, let's say I called out sick today. Who would cover my class? A substitute. That's someone who comes in and fills out the spot that I would be here, you know? They would do whatever they do at the front of the class. So a substitute is something that we're putting in for something else. Okay, cool. Now your homework last night was just to set up the 4 questions, 11, 12, 13, and 14. So I'm going to turn this worksheet over. We're going to look at number 10. We're going to talk about that beautiful setup that we've already done. We'll look at it again. And then we're going to learn how to solve it using the substitution technique. So here we go. So the first question had 1, 2, 3 sentences. The third sentence was just, hey, what are we looking for? How old are these 2 people? So we had Sally and Bob, and we know that the first sentence turned into the first equation of our given system, okay? So let me tweak this camera just a weensy bit. Better. Okay, so I'm going to look for my is, was, were, will be. There it is. And we got Sally. So Sally's on the left. We got Mr. Bob on the right. Okay? So 20 years older than Bob. Older was a plus word. Than was a switch those terms word. So we have Bob in the front. We have older. And then we have the 20. Remember, older was a plus word. Than is a flip word. B for Bob. And 20 in that second position there. Next sentence. Woo. We have 3 years ago, Sally was 5 times as old as Bob. So 3 years ago, comma, we know that all of this jazz happened. We can easily find our equal word, cool beans, and we have Sally on one side and Mr. Bob on the other. Cool. Now, this happened 3 years ago, so that's a -3 on both sides. And remember, there was always that little word in there that, well, we got to go read it, right? 3 years ago, got it. Sally, got it. Was 5 times. Ooh, I didn't use 5 times. 5 times all of Mr. Bob, including 3 years ago. So cool. We have our setup. Again, we can write them over here on the line. Perfect. But how do we solve it, right? These are not set up for eliminate. Even if I wrote them and stacked them above one another, let's take a look at that. So here's our first one. Let me grab this second one and put it over here. No, nothing lines up. This would definitely not be set up for our vertical alignment method, aka our eliminate method. Let me turn that camera just a wee bit this way. Because I don't have the S's lined up, the B's are all tweaked, they're not lined up too. So shenanigans, what do we do? So what we're going to do is we are going to take one equation and shove it into the other equation. Literally, violence is happening. Just kidding. So we're going to take the top equation and replace it into the other equation. You're like, ooh, how does that happen? Well, I know a secret about Sally. Let's take a look. Sally is this. Sally is this. Anytime I see Sally, I know this. So if you see an S anywhere, you can literally replace it with B plus 20 because they mean the same thing. B plus 20 and S are equal. So let's go to the second equation and see where an S is located. No, 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 yes. I literally can replace or substitute in for Miss Sally what I know about Miss Sally. And I know that Miss Sally is B plus 20. They're equivalent. So I'm going to take B plus 20 and drop it into that spot. So I'm going to replace this into here. I'm literally going to drop a B plus 20 in that little teeny location. So let's do that. So instead of S, I'm replacing it with what I know about Miss Sally. And that's B plus 20. And then the rest of the equation stays still. Nothing else happened. I literally grabbed the first equation where I knew a secret about one single variable. One single variable, Sally, I know is B plus 20. So any place I see Sally, I can replace it with B plus 20 because I know Sally is B plus 20. They're equivalent. Now, I really don't need these parentheses. It's just a protective measure, just in case maybe there was a number there that you might need to distribute. But in this case, we don't have anything sitting there. So I'm going to remove our parentheses. And I'm going to start simplifying each side of this equation. I can see one side of the equation, I have some like terms. And on the other side of the equation, I have some distributing to go through. So let's check it out. B plus 20 minus 3. Oh, I know this. You know that. What's 20 take away 3? Yep, 17. And on this side, I have a beautiful distribution problem. So 5 times B, remember distribution is a fancy way of saying, hey, let's multiply the sucker. 5 times B is 5B, and 5 times negative 3 is negative 15. Cool. Now we have a problem where we have letters on one side and numbers on the other. I'm going to move this over here so I have a bit more space. Perfect. I like to draw my line. Now take your hand and put it on the letter. Oh, bloop, and bloop. Oh, and they're on opposite sides of this beautiful divider line. So that means this guy needs to come over here and join his friend, or this guy needs to come over here and join his friend. You can do whichever you choose, okay? Both will give you ultimately the same answer. So we have to move the B guys. Now, technically, if you're a visual learner like me, there's a 1 sitting here. I'm going to show it. Hey, Mr. Bob. Yeah, there's more Bobs over here. Let's go join them. How do I move a 1B to the other side of the equation? Do you remember that? How do we move a term to the other side of an equation? How do we do that? Take the opposite? Bingo. Or subtract? Yes. So the opposite of 1B is minus B, and whatever I do to one side, I do it to the other, right? Cool, minus 1B. And notice this dividing line allows me to see the two sides. As a visual learner, I appreciate that. These cancel, bloop. I have 17, let's drop that sucker down. I have 5 Bobs, 1 Bob no longer is there. So if you have 5 of something and you take 1 away, you're left with 4 Bs. Beautiful. Cool. Looking a little better, right? Now I have some like terms here too. I'm a regular number, you're a regular number. Man, we should hang out. We can probably be friends. So this 15 would like to come on this side of the equation and join his friend. Well, we do that, why? Opposites. We're going to do the opposite of minus 15, which is add 15. And whatever we do to one side, we do it to the other. Right, okay. So I'm going to add 15 to both sides. Bloop, bloop. 15 take away 15, bloop, cancel. I'm going to drop down that 4B. 17 plus 15. Now be careful. 17 plus 15. This is not the part where you want to make a silly goosey mistake, right? This is the part where I would make the silly goosey mistake, and that's frustrating. I did all this great math, and then I can't add two numbers. So take your time. Take your time. There's no rush, right? So 7 plus 5 more. 7 plus 5 more. 7, 8, 9, 10, 11, 12. Put the 1, bring down the 2. 1, 2, 3. Perfect. We're not done because I know that B is not by itself yet. I need to solve. So I need to get the variable isolated, which is just a fancy word of saying, hey, get that letter by itself, okay? So we're going to isolate the variable B. That means this Mr. 4, you got to go. So what's the opposite of multiply by 4? What is the opposite of multiply? Divide, right, good job. So we're going to divide both sides by 4. Boop, cancels. B equals 32 divided by 4 is 8. Good job. So that means Bob is like Bobby, because I don't know many 8-year-olds named Bob. Bobby? Sounds good. So we're going to bring this over here, because we know Bob, also known as Bobby, is an 8-year-old kiddo. But that doesn't give me Sally's age. So remember, we have these two equations in the beginning. One of these would be easier to use than the other to find out the missing age, Miss Sally, okay? We do know a secret. Sally is Bob's age, add 10 more. Sally is Bob's age, Bob is 8, plus 10 more. Now, if your brain went 18, bloop, you're done. But if your brain doesn't operate that way because you're a visual learner or maybe a body kinesthetic learner, you need to do all the math to get there. And that's okay. All types of brains are beautiful brains. All types of brains are brilliant and smart and perfect. What we need to do is just figure out how our brain works and respect it. We got to respect it, okay? Now, I'm a visual girl, so even though I could do the math in my head, I know me, I shouldn't trust me, so I'm not going to. So I'm going to write down that equation, put in what I know about Mr. Bob, and I know that Sally is an 18-year-old beautiful young lady. Perfect. So this was a pretty long video. I would recommend that you watch it a couple times. I'm going to do a couple more of these, and then I'm going to give you the answers, because I'm not going to do them all for you, but I will definitely give you the answers. So I'm going to stop this video. And then I'll do maybe 1 or 2 more. Okay? Great. Good job.